What you are looking at right now on screen is my mobile device completely got hijacked while visiting www.example.com, and it says you have been spoofed, DNS spoofed, and this is no malware, no virus, no suspicious download, just one attack, which is DNS spoofing. So by the end of this video, you will understand exactly how this works and how hackers automate it without touching the victim's computer, and the most importantly, how you can protect yourself. So let's get into it. Before we hack anything, you need to understand what DNS actually is. And if you don't know, we have created a previous video on what is it, all the history about DNS. So it will be easier if you watch that and come to this video. But yeah, let's go through it very quickly. So whenever you search google.com, your browser doesn't understand what google.com is and where does it live. So it basically do these following steps. So in step one, your computer asks the DNS resolver key, hey, what's the IP address of google.com? The resolver checks its cache, and if it presents in the cache, it just gets the IP address and send it. And otherwise, if it's not present, it will then go on to the top level domain servers, and finally Google's own name servers will be hit. So it gets back the IP address and Google website loads. So all this process happens in millisecond, and it's completely invisible to you, which exactly is the reason why these attacks are so dangerous. So let's see what DNS spoofing is. So DNS spoofing is also called as DNS poisoning. Is it is when an attacker tricks your computer into believing that the fake IP address is the real address for that website. So instead of google.com pointing to Google's real name server, it points to the attacker's machine, and the attacker's machine is running a fake Google page. So if you imagine you typing password and you think you are logging in, but you are just handing your credentials to the hacker. So this is how a lot of real world phishing attacks actually work at the network level. Not a fake email and no links, which is sketchy, right? So legitimate URL as well, but it's just the DNS which has changed. So two main ways attackers pull this off. So method one, manually poison the DNS setting on the victim's device, and method two is use ARP spoofing to automatically intercept all DNS traffic to the network. And we are going to demonstrate both of it today. So let's see how our setup is looking. So before we run the attack, let me show you like what all setup I have done. So everything you are about to see happens in a completely isolated environment. So I have created two virtual machines on my Mac, and both having private networks. So nothing we do here touches the real internet. So number one machine is the Kali Linux, which I have installed, and it has the IP address, which I will show. And since it's a private network, there is no harm in showing IP address. So Kali basically is a Linux distribution built specifically for security research and penetration testing. And number two is Debian Linux. So it's a lightweight machine. That is why I have installed, because it's the client side which we are going to review or see is just the commands which we need to run. So we just need terminal for it. So I have kept it very lightweight. First, we need something to serve to the victim when they land on our fake site. We'll create a simple HTML page that will just say you have been DNS spoofed. In real attack, this would be like pixel perfect clone of, let's say, a bank's login page. So you will enter your credentials and you may not know if it's legit or not. You may think that it's a bank's page, but it will be not. So, but for this demo, we'll just keep it simple. So yeah, I will paste this command. So your mkdir if you don't know, just creates a new folder if it does not exist already. And echo command is something which we are just writing into our file, which is index.html. So if I click enter, it has created it for me. So step two will be to start the fake web server on port 80. Now we need to actually serve the page over HTTP so the victim's browser can load it. We are going to use Python built-in HTTP.server module. It's installed already on every modern Linux system, so we don't need to set it up by ourselves. So let's just go on to this particular directory. I will just go on to this directory and run this port 80 using Python. I will just quickly enter the password, and this port is live and up. So port 80 is a standard port for HTTP traffic, the same port your browser uses by default when you visit any website. So when the victim's browser makes a request to example.com, let's say, it will hit our machine on port 80 and receive this fake page. A fake website is now live. So we'll just open another terminal and keep this up and running in the first one. Okay, so next step is very critical step. We are going to use a tool named as DNS Chef, and DNS Chef is basically a fake DNS server. So whenever victim asks where is example.com, it replies with whatever IP address we will tell it to instead of the real one. So think of it as like a corrupted phone book. You look up to the name and it gives you the wrong number on purpose. So DNS Chef is a system package which we can install on Kali, and it's the latest version of Kali, so no worries in installing that as well. So no manual setup. Yeah. So we'll just run this command, which is, let me break this command down for you guys. If you don't want these explanations of commands, you could skip and go on to the further section where we will actually run this. But yeah, I will quickly tell what each of these things do. So fake IP is the IP which we want it to return for the spoofed domain. So this is our own Kali IP, and this is the IP which this machine holds. Cool. So I will quickly show you this the IP address for this Kali Linux. So let me see. So I have run IP A, and it returns me this IP address, which is exactly what we mentioned here. So it's fake IP will basically point that this is the IP which you are looking for. And if the client searches example.com, even though it will be on a different IP, it will make this IP as that one. So yeah, this is what it does. So fake domains example.com is something which we are going to affect, and it's the only spoof to this specific domain. All the other DNS queries get forwarded to real DNS servers normally. So we are just going to affect this particular website. And interface is something which you don't need to worry about as of now. It's just basically giving the permission for all the networks to reach on this DNS server. It's okay if you don't understand it. That's not pretty important. So I'll just click enter and quickly enter my password, and this DNS Chef is up and running. So whenever we will visit this website, we will see the logs. And point 4 basically, and the step 4 is point the victim's DNS. So at this point, we have set everything we needed to on our Kali. Now is our time to set things on our victim's website. So now the victim's machine is Debian, which is the Linux which I have installed. We need to tell it to use our fake DNS server instead of the real one. In real attack, this step happens automatically through our ARP spoofing, which we'll cover in the next section and very soon. The attacker never touches the victim's machine. The file we need to edit tells the operating system which DNS server to use for all lookups, which basically is resolve.config. On Debian minimal install, there is no sudo, so we switch the root user first. Now is the time to set things up on the victim's machine. So we are going to use Debian for it. And the first thing which we are going to use is the sudo command for changing the resolve config file. So yeah, here we have the resolve config, and look how we have two name servers, and we'll just need one name server, and it will be the one which our attacker's IP address calls up to. And I'll just save this. Now let's check if this change is actually applied or not. Let's see. Okay, perfect. So we have changed the name server to this. And what exactly it does is it will point to, so the DNS of victim's machine is will now be pointing to the attacker's machine. Before we make the HTTP request, we can confirm if the spoof is actually working or not. So host example.com, we see this name and address as well. So this is the address of our set attacker's IP address, and look how it gave us the logs for it. And by the way, this is the IP address of our victim's machine. Okay, so yeah, this is interesting. So host command queries a specific DNS server, in this case our fake one of Cali, and let's see running the example.com in machine. So we will just use the curl command, which basically will load the which does the same thing as our browser. So it's same as visiting this on Google. So if I click enter, this is an unexpected behavior which we just saw, like the DNS settings automatically reverted back to the original values. And this was not exactly an accident, but it's a security feature called DHCP lease renewal. So here's what happened behind the scenes. So your router is constantly running a service called DHCP, which is nothing but dynamic host configuration protocol. Every device on your network gets an IP address, a gateway, and a DNS server from your router automatically when it connects. And periodically, every few minutes or few seconds, this router checks your device if the settings are renewed or not. So when our victim machine checked back in the router said, hey, your DNS server should be not the one which is present. Like it's that the IP address which is present is for the machine which is not your current machine, and the victim machine simply updated the settings automatically. This is actually like the perfect example of layered security working in real time. The device wasn't just sitting there blindly following whatever DNS it was told. It was constantly verifying and correcting itself. That is why we saw like a different outcome just now, even though we saw the spoofed outcome a few seconds back. Okay, so we just did the manual DNS spoofing. It worked, but it required us to manually change the victim's DNS settings, which in real world never happens. So in real world, an attacker just can't walk up to your laptop and edit the file. So how do real attackers and attacks happen? So the answer is ARP spoofing. So ARP stands for Address Resolution Protocol. It's low-level network protocol that maps IP addresses to, so every device on a network maintains an ARP table, essentially a local record of who's who on the network, right? So in normal network, the victim's ARP table says the router is at MAC address and whatever the MAC address is. So all the traffic goes to the router which sends to the internet. In an ARP spoofing attack, the attacker sends fake ARP messages to the victim saying, "Hey, I am the router, send all your traffic to me." The victim updates the ARP table with the attacker's MAC address, and now all the traffic, including the DNS requests, flow through the attacker first. So attacker intercepts the DNS query, poisons the response, and forwards everything else normally so the victim notices nothing. And this is called a man in the middle attack, and it's completely silent, no alerts and no warnings and nothing else. So I did try to perform all these things on my mobile device via my laptop, but now the modern technologies are smart enough to recognize which DNS IP is connected. So as we saw earlier in the unexpected behavior part, like the system itself checks if the IP address which is being added is genuine or not. But if unless we manually does not change the IP address of the router in a certain device, it will not work at all. Also, once you get connected to the attacker's machine, you will only see logs in the attacker's machine. You will not see any data which is decrypted. So all the data which you will see in the logs will be encrypted and will not be in a human readable format. And I will share the screenshot here of what I did in my mobile device. So try to do something on the other electronic device, which is a television. And televisions like devices does not send any encrypted data. So the packets which were being sent were easily readable, and it was easier to make anything crash on the television just by this attack. So modern laptops, computers, mobile devices, and other electronic devices are very much encrypted. There are a few electronic devices which does not require any encryption level of complexity. That is why those are like easier to um, get into these attacks without any manual change. And I could not show all the process which I did for this real world implementation of screwing my own mobile device and television due to its sensitivity, given that it's not something you may want everyone to know. So, yeah. So, a few real world implications to this would be, I will give a few scenarios where you could imagine this attack happening. So, first scenario would be a public Wi-Fi. So, you might be under an ARP spoofing attack and your DNS is now poisoned. You open your banking app and the domain resolves to their machine. So it's a scenario which has to be a perfect clone of your bank's website, and you log in and they have your credentials. So basically your username, your password will be passed via their system to the internet. And again, this will have a layer of encryption, so you may not have to worry much. But yeah, we never know which applications support it, but most of it do support the encryption of data once the data is being sent from your current device. Second scenario would be a corporate site. So an attacker gets onto your company's internal network. They poison DNS for the company's internal tools like Slack, email, VPN portals, etc. So the employees log in and the credentials are harvested silently. All right, so now is the most important part. So, how do you protect yourself? Defense number one would be to use DNS over HTTPS. So, instead of sending DNS queries in plain text, an attacker on the same network can't intercept or tamper your data with the encrypted DNS. You can enable this in Chrome and even the OS level on Windows and Mac. Chrome, you have these settings, just search security over here. You will find this security tab, or you could also see the URL and go down. You will see the option of use secure DNS, and it will be on by default. And this is the one which should be on always. The defense number 2 would be use DNS over TLS. So similar to previous case, but at a lower level. So encrypted DNS traffic using TLS, the same protocol that secures HTTPS websites. Cloudflare and Google both support this particular feature. Unfortunately, we don't have the enable option for DOT, which is DNS over TLS in Mac, so I might not be able to show how it's done. But you need to understand the difference between this DNS over HTTPS, which is DOH, versus the DNS over TLS, which is DOT. So DOH encrypts DNS traffic by wrapping it inside regular HTTP on port 443, and DOT encrypts DNS traffic using TLS at a lower network level on port 853. So DOT is cleaner and more isolated. Network admins can see DOT traffic via port 853 and block if it's needed. So imagine this as having a building and there are multiple doors for entering the building, and DOH basically is the main door and DOT is the door which says only DNS requests. So any network entering the DOT port, which is 853, is with the only intention of DNS network, and DOH basically blends in with normal web traffic which lies under the HTTPS. And TLS here is basically transport layer security, and it is a protocol that encrypts data sent between two devices over the internet. So when you visit a website with HTTPS, TLS is what's doing the encryption behind the scenes. It's S in the HTTPS stands for TLS. Reference number 3 is DNSSEC. So DNSSEC adds cryptographic signatures to the DNS records. When your resolver gets a DNS response, it verifies the signature. If the signature doesn't match, it knows the response was tampered. It's a digital seal of authenticity on every DNS record. Defense number 4 would be always to check HTTPS. And this is very manual and something which could be easily done. Even if the DNS is spoofed, a proper DNS certificate is very domain specific. If you land on a fake site, your browser will show certificate of warning. Never ignore the certificate warnings ever. Defense number 5 would be to use VPN. So VPN encrypts all your traffic, including DNS queries, before it even leaves your device. So on public Wi-Fi especially, VPN is your best friend. So there you have it, DNS spoofing from ground up. We built a real lab attack, performed manual DNS poisoning, learned ARP spoofing for full automation, and covered exactly how to defend against it. The goal of this video is not to teach how to attack people, but the goal is to make you understand how these attacks work so you can protect yourself and your team and your users as well. Hiding something doesn't make it safe. Knowledge is the only real defense. If it was helpful, drop a like. It genuinely helps the channel. Subscribe if you want more deep dive security content like this. And let me know in the comment section what attack do you want to see next. I'll see you in the next one.